All right. 153B. What am I doing? I am finding the inverse. Okay? So what do I need to do to find the inverse?
Switch X and Y.
Switch X and Y, so that's Y. So X equals 2Y plus 1 over 3Y plus 5, okay. Now what?
Try to isolate Y.
Gotta get Y by itself. Alright, how do I do that? Bring this over to here. Okay. Now what? Yeah, there's two Y's here, they gotta be on the same side. So I'm gonna just rearrange my problem. And it doesn't matter which way you rearrange it, but you wanna have all the Y's together so that you can factor them out. And then divide. So your inverse is going to be negative 5x plus 1 over 3x minus 2. Tell me about the domain of that inverse. X can't be 2/3, can it? Probably should get in the habit of that. It's pretty important. Now, we talked about this, I think we maybe did this exact problem in one just like it. If you look at the original function, if you were going to graph this, your vertical asymptote would be at negative 5/3, because X can't be negative 5/3. And your horizontal asymptote would be at 2/3. When you do the inverse, then doesn't it make sense that your vertical asymptote would now be at 2/3 and your horizontal asymptote is at negative 5/3? Yeah. Okay?
Can you do 5C on 1.5?
5C, that will be the one right after. Oh, 5C. 5C. I think I need. Can I need my equation or no? Let me see. Exchange rate was Y equals 1.08x. So how many euros would you get for 100 US dollars? X is US dollars. So A is just 108, right? Mm-hmm. And then the inverse function, so the inverse function of this would be X equals 1.08Y, or Y equals X over 1.08. That would be the inverse. Mm-hmm. And then the tourist had an elegant lunch. 48 euros, how much was that in US dollars? So keep in mind that in the original equation, what was Y?
Euros.
And what was X?
US dollars.
Okay, so I need 48 euros. So 48 equals X over 1.08. Or do I have that backwards? I think I have that backwards, don't I? Because I need.
That equation's euros to dollars.
Yes, this equation is euros to dollars. So that's the equation I need. So I need 48 over 1.08. Yeah. Because this equation was dollars to euros. This one is euros to dollars. dollars, and that's what I want, okay. Alright, so 48 divided by 1.08. 44.44. And that was dollars. So remember, if you get confused by that, Lucy, remember that euros are 1.08 times dollars. So euros are bigger than the dollars. So if you get confused about which way to go, if you're going from euros to dollars, in this, I don't know what it's like really in real life, but in this problem, it's dollars or less. So we wouldn't be multiplying by a number bigger than one, we'd have to divide.
Okay.
If you get confused about what equation to use.
Can you do number 3 on 1.6?
Okay, so let's remember what odd means. What does odd mean?
Symmetric on the
Origin.
Origin. And if you're symmetric about the origin, what does that mean?
It means you can make the
You can
y and x
you
negative.
change the sign on both variables and the equation stays the same, right? So in other words, if you change the sign on the input, you also got to change the sign on the output, because if x changes, so does y. Okay, so what's our equation? Y equals negative 3x to the 7th plus 2x. So there's the original equation. That is what I am trying to match. If I change the sign on both the x and y. Right? Okay. So what happens here? Well, negative to the 7th is going to be
Negative.
negative times the negative, so it's going to be positive 3x to the 7th minus 2x. Dividing by the negative to get y by itself so that I can compare it to the original.
Yes.
Yep. So odd means that if you think of a function, odd means symmetric about the origin. Okay, but to make it, think about it in another way, think of the function y equals x cubed.
It's odd.
Is that an odd function? Think about what the picture looks like. Is it symmetric about the origin?
Yes.
Yes. So, think about what happens if you put in a 2. If you let x be 2, then y is 8, right? But what happens if you put in negative 2?
Y is negative 8.
So in other words, that's, if you change the sign on your x, you're also going to change the sign on your y. That's what odd means. You're reflecting across the origin, which means both signs change, right? Both signs change. That does not happen with this. Because here, if x is 2, y is 4. What if x is negative 2? Y is still 4? This is an even function because changing the sign on x doesn't impact your y across the y-axis, right? So even means you can change the sign on x and nothing happens. Odd means if you change the sign on x, you're also going to change the sign on y. Okay? Got it? All right, anything else? Tess? 1,6 C. So I'm sketching f of 1/2 x plus 1. And my original picture like this. Okay? Right? Alright, now, what changes are being made? What does all this do? What's happening?
Multiplies x by 2.
Okay, so this number divides the width. So all the x's are gonna be divided by 1/2. So basically, this thing's gonna be twice as wide as it was, right? And then what does this do? Up 1. So you can do this all at once. I'm gonna do it in pieces just because that's the way my brain works. But I'm gonna take every x thing and make it twice as wide. So, how wide is this trapezoid right here? Right now?
5.
It's 6 wide, so now it's gonna be 12. So this guy is gonna come all the way out to 1, 2, 3, 4, 5, 6, 7, 8. It's gonna be 1, 2, 3, 4. So there's my first part of my thing. This is gonna come out to 4. This thing's now gonna be 4 wide. Still put you down. So there's the thing twice as wide. All right, Tess? Now, what has to happen to it now? It has to go up 1. So instead of being at 0, it's at 1. Instead of being at 3, it's at 4. Instead of being down, what was that, down 2, now it's only down 1. And there it is. That pink thing is your answer. All right. What else? Turned back a lot of homeworks in this section. I feel like I have a lot of pink marks. Sabrina?
Are you taking questions under 1.7?
Yep.
Could you do number 7?
1.7, number 7. Alright, so if you haven't done 1.7 yet, then you've learned that now. Alright, Ruth's gonna get a job. One offers a base salary of $25,000 plus 5% in sales. And the other offers $20,000 plus 7% of sales. What would Ruth's gross sales total need to be to make the second job offer more attractive than the first? Okay, so first of all, does it make sense to you that if she sells a whole bunch of stuff, that this would be the best way to go?
Yeah.
Because eventually 7% is gonna be better than 5%. But if she doesn't sell very much, then she's better just sticking with this plan, right? So your job is to figure out what's the tipping point. Where does she have to make, or where does she have to sell to make this one the way to go? So, don't we want, basically, we wanna know when is I'll call this the second job. When is the second job giving me more money than the first job? Is that basically what we're doing? How much money does she make with the second job? Well, she makes 20,000 plus
0.07.
0.07x, if x is the amount of sales. And we want that to be bigger than 25,000 plus 0.05x. Sabrina, does this make sense to you?
Yeah, that's what I had.
Alright, so let's start solving this, let's see, I guess I'll go this way. So 0.02x is greater than 5,000? I'm doing this without a calculator. Now I have to divide 5,000,
I got 25.
I'm giving up
I got 25,000 too.
divided by 0.02.
I got it right.
You just have to say 25,000.
No, 5,000. I was gonna say, that's too cheap.
Final.
5,000 divided by 0.02. I got, 250,000. So basically, she has to sell more than $250,000 worth of stuff to make this the way to go. Tess? Have you tried 6, Tess? I don't recall grading your paper. Okay. We need to try it first. Just because it looks hard, that doesn't mean the teacher's gonna do it for you, right? You try it first, and we'll talk about it.
Can you do a 5 on 1.7?
I haven't graded your paper either. Is it done?
Yeah, it's done.
Okay. Number 5. Okay, this is the last 1.7 I'm doing because I want you to try them first. I can't, it doesn't do anybody any good for me just to stand up here and do your homework for you. All right, but since she's done number 5, I'll go ahead and do it. All right, so a tire of a moving bicycle has a radius 16 inches. If the tire is making 2 revolutions per second, so that's where I'm starting. 2 revolutions, 1 second. Find the bicycle speed in miles per hour. So eventually I want to end up with miles per hour. So I gotta get from there to there. Well, time is always the easiest for me anyway, because I know that there are 60 seconds in 1 minute and 60 minutes in 1 hour. Well, that is perfect, because now I have hours right where I want them. So now gotta get from revolutions to miles. Well, somebody got hit on this yesterday. Was it you?
Yeah.
Yeah, a revolution is a circumference, and a circumference is a distance. So we can get from revolutions to distance by remembering that a circumference is a revolution. So, what's the wheel size here is 16-inch radius, which makes the circumference 32 pi inches per revolution. So now that's gone. But now I've got inches and I need miles, but that's pretty easy. So I'm gonna multiply, I'm gonna be off the video here in a second. So inches is, let's see, 1 foot, 12 inches, 1 mile, 5,280 feet. Is that gonna leave me with miles per hour? It sure is. So 2 times 60, times 60 times 32 pi. That's it for the top. And then I have to divide by 12 and divide by 5,280. So I got 11.42 miles per hour if I type that in correctly. Okay? Alright, so what else from a paper that I graded?
Sure.
Anything from the review sheets, you were looking at the review sheets, and you found something in there.
Remember, for this is a 1.5, 3C, I put
Which one is that?
3C.
Alright, so now we're looking at homework 1.5. Alright, so let's pay attention here. Let's pay attention here. Homework 1.5, 3C says here's the function. Now find the inverse. Okay, looks a lot easier than the other one we did. So the function is y equals the square root of x. So x equals the square root of y, and y equals x squared. But here's the problem. This is the inverse, no question about it. But here's the problem. What does that look like? That's a BFF. What does that look like? Isn't that this?
Yeah.
What does this look like? This?
Yeah.
Now, here's the problem, kids. Functions and their inverses have the relationship that the inverse is formed by taking the ordered pairs of the original and flipping them. So whatever your inverse is has to come from flipping these ordered pairs. Is there anything negative in any of those ordered pairs? You got negatives over here. That can't be, right? Goes back to domain. What's the domain of this guy right here? His domain is 0 to infinity. What's the range of this guy right here?
0.
Same thing. So when you find the inverse and you flip those, doesn't the domain and the range for the inverse basically have to be the same thing? Because this becomes the domain, and this becomes the range, but they happen to be the same thing. So look at what you told me the inverse was. What's the domain of this? Can't be. It can only be the right half. That's it. That's it. So finding the inverse is more than just switching the variables. Yes, you switch the variable, but you've got to think about what those variables were in the beginning. Because when you flip them, they don't change, right? So if they weren't negative in the beginning, they can't be negative in the end. All right? Okay. Anybody find something else, either on a homework problem that I have graded and given back to you, or on some of the review materials that I gave you yesterday? Lucy?
I have some question if you decided whether or not our test is gonna be Thursday or Friday.
Well, our test should be Thursday.
Okay.
But the problem is, Thursday, we have 40-minute periods. I am not comfortable with that. So we're gonna have it Friday. Okay? Thursday, we have our first, used to be county, what's it called now? Yep, our first core meeting.
I didn't even know.
I thought we had another assembly. I'm like, wow, another assembly for the fifth time.
No, it's our first core. Well, and this, we don't have very many of them this year. Tomorrow, Thursday. Okay, which I'm okay with. We're still on track. He's giving his test Friday too, so it's fine. We'll be fine. Liam?
You do homework 1.5, number 4.
Yes, if I haven't already, I feel like I've done, nope, I haven't done that one. So, we just spent some time finding an inverse. found the inverse. Somebody else has figured out that these two are inverses of each other. All right, somebody already did that. Now, our job is to prove they're right. So I want you to think about what I was just talking about with that parabola and that square root. When you find an inverse, you flip the ordered pairs. So in other words, if you were to plug, let's say a 5 into this function, your ordered pair would be 518, right? If you put an 18 into this one, you get 5 back again. That's what has to happen if they are inverses. Doing it with single numbers doesn't prove anything though. You have to do it in general. So the idea is, I'm gonna put x into this function, and it's gonna give me something, and then I'm gonna take that something and put it into the second function, and it's gonna give me back my x. That's how you prove things are inverses. So you build the composition, f of g of x, and g of f of x. Because in both cases, you're taking x, plugging it into one of them, taking that answer, plugging it into the other one, and this has to come out equaling the x that you started with. So f of g of x means plug g into f, so it'll be 4 times x plus 2 over 4 minus 2. Remember, this means take the g function and plug it in right there. Well, does that work out for me? Yeah. Then this one means take f and plug it into g. Does that work out for me? Yep, that's your proof. That is your proof. Okay, Mr. Fahey? Now, let's suppose I have this situation. Now, they're not inverses, but let's see, if I plug in 5 and get my 18, and then I take my 18 and get 21 over 4, can I say they're not inverses based on that one specific example? Yes, it's called a counterexample. So you can disprove with a specific number, but you can't prove with specific numbers. You have to use x's to prove. All right, what else?
Would you do on the practice, the Mr. Knowles practice?
Mr. Knowles
Would
practice?
you do number 1?
The piecewise function?
Yep.
By the way, there's some talk of making this class an AP class next year.
Pre-calculus AP.
That's the talk. It's gonna be a new AP course next year. Not sure how that works, since pre-cal isn't a college class, I'm not sure how that's gonna go. But anyway, so if they made honors pre-cal, an AP class, would that matter to you in any way, shape, or form? Would it make it worse for you, easier for you, better for you?
Will where in the curriculum still be the same?
Pretty much. There'll be a couple of modifications
If they do
that I
it.
may actually throw in this year just for practice, but yeah, there'll be a couple of modifications, not a huge deal. Would it matter to you? I mean, if instead of being called honors pre-cal, if this were called AP pre-cal, would that matter?
That would boost our GPA, right? It would put our
No,
GPA
it's the
up.
same GPA.
It'll be the same
Yeah.
GPA.
Well, it's cool to take more APs.
Huh?
We have an exam in May for like college, but it's not college
Yeah.
class.
Yeah.
And how you
It was an
credit.
AP test. Yeah.
Wow.
It'll be an
Then
What's
does
the point
it
of
does
that?
so, but then
Well, what's
does it
the
count
AP
here,
math
is
bro?
before I have, does
Would
it
you
count
look
your
at
calc credit as
the
college?
math?
Oh, no, it's not a calculus class.
So this,
So you would still take AP calculus or calculus when you get to college. This is not a
Then what's the
calculus.
point in making an AP class?
I don't know.
Whose idea was this?
It's not mine. It's college board. They have this thing called AP pre-calculus right there. Yeah. So, and Cathedral is talking about doing it next year, and I just wondered from the student standpoint if it would matter to you. Okay, because you're taking this class anyway.
yeah.
So there would be the additional component of an AP exam, but then no final exam. You're gonna take my final exam. But if it were an AP class, you wouldn't have that, you'd have the AP exam instead.
So,
So it's
would
not-
it
it's not
make
the-
it look better on our transcript?
I don't know. I
Yeah.
guess if it did, that would be a benefit, right?
Yeah.
Like seniors also take it.
Huh?
A lot of seniors will take it, because it's their senior year and they want to try harder.
I think that if it were like an AP class, I wouldn't take it because like it just feels like it'd be more stressful at the end of the year. Because like with the final, it feels like it's much easier to like prepare for that than an AP test.
Yeah.
Understand though, if Cathedral offers it, it will be just like in English. You know how in English, if you're in junior honors English, you're in the AP English class. So if you're in honors math for this course, if they offer it, it will be AP. There won't be AP and honors. It will all be AP, just like it is in English. I don't know, spend some time thinking about that. We're trying to decide. It doesn't matter that much to me, I guess, because, well, I don't know if I'll be the one teaching it anyhow, but if I am, it doesn't really matter, because it's the same material, basically, with some changes. I just didn't know from a student standpoint, because that's what this is about, you guys are, what this is about, so. All right. First thing I do when I do these, and you do not have to do this, but I work better visually. So I'm gonna put a couple of squiggly lines at where I know my graph is breaking. My graph is breaking into pieces at -1 and at 2. Now, I'm gonna graph each piece, and the order you do it doesn't matter, I'll just start at the top. What does 2 minus x look like? What is 2 minus x?
It's like
It's a line.
inverted X.
It's the
Up
same
2.
as -x plus 2.
Yeah.
Isn't it just my identity,
Flip.
up 2, and backwards?
Yeah.
Or upside down, maybe is a better word. So that's supposed to be a straight line. That is a straight line. I do not want to keep the whole thing though. I only want to keep the part of that line, well, that's less than -1. So here's where it is, where x is -1. This is where x is less than -1. So I don't even want all this. This isn't even part of the picture. Not part of the picture. I only want to keep the part of that line that's left of -1. All right, what's the middle one look like? What does this look like? Y equals 2. That's a horizontal line through y equals 2. Now notice, here's where it's -1, here's where it's 2. -1, oh, whoa, my pink dot needs to be colored in, did you notice that? That's or equal to. This one is not or equal to, but this one is. And what part of that horizontal line do I want to keep? In between the dots, right where X is, in between the dots, so there it is. I don't want this part, and I don't want that part. What's this?
A parabola.
a parabola
Shifted down 4.
down 4. So if I just graph the whole parabola, there's what I get. But I don't really want the whole parabola. Here's where x is 2. Open dot. And I only want the part of the parabola that's
Greater.
that way. So I'm gonna get rid of the rest of the parabola. I'm gonna get rid of my squiggly lines. And there is my piecewise function. I use those squiggly lines so I know where the dots are. I gotta get the dots in the right place for the different pieces of the function. Notice that these dots are on top of each other and these dots are on top of each other. That's as it should be. But you're never gonna have two solid dots on top of each other because this is, after all, a function. So you can't have two solids on top of each other. Let's talk a little bit about that. Yeah, give the domain and range. What's the domain of this function?
Sure.
All the numbers.
All the numbers, right here it tells you. Doesn't x cover it all? Less than -1, between -1 and 2, bigger than 2, that's everything. What about the range though?
-2. Not included to infinity.
Doesn't parabola up to the line.
You go from
You gotta
negative.
figure out, I think I might have this point in the wrong spot. It's okay, but I gotta figure out where that is, cause isn't that the lowest point in the picture?
Yeah.
So that's gonna be the bottom of my range, whatever my range is, it's gonna be that value on up. So I need to find out where that point is. Well, let's look back up here for a second. How could I find out where that point is? What do I know about x? It's 2, and if x is 2 on that parabola, then y is 0. So actually, this curves up like this. So my range is 0 to
You just plugged it up.
we knew what x was. So we just plugged it in to find y. Alright,
I thought that.
anything else?
On the back of that page, the one at the bottom, the numbers cut off, but it
You know that
says
this x is
absolute value of x plus 3.
Uh-huh, yep. So, you want to graph it on your calculator?
2 squared minus 4 is 0.
You can do that, right? And I'm using a standard window. Mr. Knoll kind of set up a window for us if you want to use that. But I'll just use a standard window. I'll go to y equals. How do we get the absolute value? Math, number. So x plus 3. And then plus another absolute value. X minus 1. And then just minus 6.
It's in the basket. Which question is it? Which question?
Okay. So it looks like, let's see, 1, 2, 3, 4. So it looks like are you kind of seeing that?
Yeah.
Okay, so what do I want to know? Graph it, identify intervals on which it's increasing. All right, where do you think this thing is increasing? Right here, right? So what x value do we start with there? Isn't it 1? I think it's 1. And forever, it's increasing forever? Alright, where's it decreasing? Negative infinity down to here, which is -3. Right?
Oh, yeah.
I think it's -3.
Oh, wait, -3, actually.
And then where am I constant? -1. It's just a horizontal line. Yeah.
And then once, like, problem 2 above that, will we be able to use our graphing calculator on that?
Mm-hmm.
And then just graph
Now,
that?
to graph it, now I would expect you to be able to find the domain and range of that
Just looking
without
at
a calculator, but yeah, to graph it, we use a
Okay.
calculator for that.
But then the other one next to it, we could graph that.
So we're allowed.
Yes, that one would be easy to graph,
Okay.
yeah.
So we're allowed a calculator and stuff.
Part of it,
On all of it?
part of it. Get over it.
Because you already had a calculator.
No, I didn't.
You did do that lucky girl did do that.
I need that calculator, bro.
Alright, what else have you found? Come on. Be great if we all got a good grade. Where? Back. Alright, Chris is looking at the Mr. Knoll's packet, the very back side of the whole packet. It says determine the regression equation. So this would be a calculator exercise. Now, that data looks pretty crazy to me. So let's put it in. So stat edit, right?
Yes.
Is that a 1? Now, I got the data in my calculator. Do you have it in yours? What I'm not, Sabrina?
Yeah, how do you do the plot? Sorry, I was finishing.
Okay, yeah, what I'm not sure about, remember, our calculator has a lot of regressions, right? It'll do all kinds of regression. I'm pretty sure this isn't linear, but I don't know, if it's quadratic, cubic, I don't know. So I'm gonna plot these points, okay? So I'm gonna go to Window first and make sure that I can see the points I'm plotting. So the x's go from 3 to 18, so I might let my x's go from 0 to 20, just to get them all in there. And then my y's, I might go from 0 to 60. Those numbers are flexible, so you can adjust them. I just wanna make sure that when I plot these points, I need to, or I have them all, I can see them all. All right? Now, go to stat plot, which is above your y equals, and turn the plot on. And then hit graph. Whoops, I also had an equation in there. I gotta get rid of that equation too. Okay, now I see my plot. Now, if you're a little concerned, zoom square the screen. Hit zoom, square, choose the square option. What do you think you're looking at? A piece of a parabola, it looks like, right? So now I'm gonna go to Stat, Calc, and choose Quadratic Regression. And that's the equation I got. This is 4, mine doesn't have fractions, mine has decimals. Yes, but look at the decimals. Isn't repeating 1s 1/9? Yeah. And isn't 1 point repeating 3s 4/3? Yeah. So there is our equation.
How did you use the scatter plot?
I put the data in, and then I went to plot and turned on my plot. So go to Stat Plot.
You go to the gas.
You're not clear. What is stat? Oh. Stat. Where's plot?
Oh wait, no, you're.
It's above your y equals,
You go to-
Sabrina. Look at your y equals key, right above it, it says Stat Plot.
Yeah.
Okay,
Yeah.
so turn the plot on. Right now it's probably off. So turn it on.
It's on.
All right, press graph. And it should plot your points.
I couldn't figure out how to get to the thing where you put in.
Okay, well, it won't plot anything if you don't have points.
How do you get to that point?
Stat, edit, right there. All right, word of caution, we just turned the plot on. For some of us, that's gonna screw up when we try to graph something, it's gonna say we can't. So you can either turn that plot off right now, or remember when you graph, if it gives you problems, you need to turn it off. You usually don't wanna have your plot on. You usually just wanna have it off. Oops. So now, look at number 2 on that, or whatever, 4B. Determine the value of y if x is 36. Well, if we now know x is 36, we can find y real easily, right? By just plugging it in. While I'm on this page, what are the vertical asymptotes in problem A? A vertical asymptote is 2, and where's the other one? 0. No? 0. 0. Factor your denominator. Vertical asymptotes are cannot be's. So in that problem, x cannot be 0 and x cannot be 2. So those are my 2 vertical asymptotes. Where's my horizontal asymptote in problem A?
Doesn't exist.
Oh, it exists.
0.
0. Kids, remember, just think about it for a second on this one. If, to find your horizontal asymptote, you want to look at your highest powers. How many x squareds do you have on the top? None. So 0 over 1 is 0. All right, second one, B. Vertical asymptote at 0. Horizontal asymptote at y equals 2. Yeah, 2x over x. Y equals 2. All right, that's enough for today. So for tomorrow, whenever I see you again, Thursday, I guess, please